Welcome to the Toxics Reduction via Responsible E-Waste Management video series, presented to you by the Delta Institute with funding from the U.S. EPA Great Lakes Restoration Initiative. In this video, Margaret Renas, project manager with the Delta Institute, brings us the presentation, Why Recycle E-Waste, Part 1. This content was originally created for a workshop series in Toledo and Cleveland, Ohio.
So the question is, now that we kind of know what is this e-scrap and the scope of the problem, why is it important that we recycle electronics properly? And there's a few reasons, and we're going to go through each of these in turn. So the first one is by recycling, we reduce energy and production resources. Second of all, there are a lot of natural resources that go into the production of electronics, and we can conserve those as well by continuing to recycle those resources back into the production stream. Third reason, we keep waste out of declining landfill space. And so here in the United States, capacity for existing landfills across the country varies, but generally there's only about 20 to 30 years left on existing landfills. Fourth reason, by recycling, we can keep some of those hazardous materials that are in electronics out of the environment. And then lastly, if those other four weren't reason enough, we get to create some jobs and help people support their families. So starting with the first one, the reduction in the use of production resources. We all have a computer on our desk, maybe a laptop or still maybe a desktop, but we often don't consider what goes into manufacturing that computer. So we can see here in this slide a tally of how much fossil fuels, chemicals, and water go into the manufacture of a typical computer. And just to kind of get our minds around that a little bit better, those resources would be about equal to the weight of a car or a rhinoceros. And no e-scrap presentation is complete without the photo of the requisite rhinoceros. And our fellow here is a little bit sad because he's not too happy about how e-scrap is being managed in this country still. Another slide on the reduction of the use of production resources. If we want to look solely at energy, this is a great slide. Energy required to recover 10 kilograms of aluminum from recycling that aluminum, less than 10% of the energy required to mine and bring that aluminum into the product. Here's another example looking at the breakdown and focusing on the conservation of natural resources and other components derived from these resources alone. We've got a variety of material components in electronics that can be recovered via recycling. There's a few of them listed here. We've got some metals, some precious metals, plastic, glass. And there's a term that's been used to describe this process in recent years, and that's urban mining, that we can recover these resources directly from our environments, our urban and suburban environments, without going back to nature. Here's another example looking at natural resources. The gold recoverable in a metric ton of personal computers greater than the gold in 17 tons of gold ore that is mined from nature. So again, just showing how that urban mining can be much more productive and efficient than natural mining. And then there's also some co-benefits to the conservation of natural resources. It reduces the environmental impacts and energy demands from mining and manufacturing. So here's a few that are listed. Enhancing human health is a big one. So there's evidence that the mining of materials like aluminum, copper, gold, lead, silicon, that these can result in respiratory problems for the miners, things like tuberculosis, bronchitis, lung cancer. Reducing the drivers of conflict. So in the Congo right now, we know there's a lot of conflict going on there. And there's evidence that operations are being financed for both the government and the rebel army through the mining of tin, tantalum, and tungsten, the 3 T's, and gold, which goes right into our cell phones. And reduction of pollution. So mining results in some cyanide-contaminated waste store. There can be toxic metals, acid, and these materials can make their way pretty easily into water bodies and end up in drinking water and affecting the health of fish that humans also rely on. Here's another great reason for recycling e-scrap. Keeps waste out of declining landfill space. So as previously mentioned, across our great country, we've got about maybe 20 to 30 years left on average. It varies place to place on our existing landfill capacity. So those landfills are getting filled up. And it's not always the easiest thing to put in a new landfill. Per RCRA regulations, there are requirements on the design and development of landfills that affect the liner that covers the bottom of a landfill, the collection system. So in landfills, when rain falls on top of a landfill, that water can percolate through and pick up contaminants, and that's called leachate, and that gets collected. And that collection system is a series of pipes, and that can be pretty elaborate. There are certain criteria in terms of the particular geology, how much clay is in the ground that's going to support that landfill, the general location, etc. And the cost of building a landfill is not cheap. We've got an example up here. The cost of constructing a 440-acre landfill in Las Vegas was about $25 million. That's a US EPA statistic. And that's just the cost of constructing it. That doesn't include design costs, operation costs, closure costs, maintenance costs. There are statistics I've seen that even adding an extra landfill cell, just one cell, to expand a landfill can cost upwards of $1 million. And then the third reason there is NIMBY, not in my backyard. Most of us don't want a smelly landfill right near our homes and seeing those large trucks pulling up. So if we can reduce the amount of electronics, which are very bulky and take up a lot of space, and keep those out of our landfills, we can reserve that space for material that we really can't handle other ways. And another reason, recycling electronics keeps harmful materials out of the environment. So there are some substances of concern that are in electronics that merit some consideration. And these substances can harm human health or the environment if they're mismanaged at the end of their life. So we're going to talk a little bit now about what are these substances of concern that are in electronics and what exactly does mismanaged mean. So here's a sampling of some of the substances that are found in electronics. We've got some heavy metals. We have some flame retardants. These substances are used in the plastic casings that make up our CPUs, for example, in semiconductor chips, circuit boards. They act as coatings for wires. Mercury lamps are found in LCD screens. So these are pretty prevalent substances that we find in electronics. And we're going to come back to those. They're called polybrominated diphenyl ethers, PBDEs. Those are another type of flame retardant. And we're going to address those in a little bit as well. So in the Great Lakes region specifically, we have some substances that have been identified in our environment that are of a concern in the Great Lakes. And this is where they intersect with those same substances that are in electronics. So quite a few of the electronics substances are substances of concern to the Great Lakes region. And again, those PBDEs, those flame retardants, those are a contaminant of emerging concern as far as the US EPA is concerned. They're taking a much more closer look at those now. And there are a couple of different types of those PBDEs that have been found in the environment, particularly in the Great Lakes region, and causing that concern. And there's two types there, penta and octa, and those have been removed from electronics as of several years ago. But there's still another type of that PBDE, the deca PBDE, that is still in electronics, and there's some evidence that it can convert to these other more concerning types, and that would explain perhaps why we're seeing increases of this contaminant of concern in the environment. And so, why are these substances concerning? Here's a couple of examples. I'm not going to read through this whole list, but there are some intestinal problems, nerve issues, nerve problems, muscle coordination, respiratory problems, neuromuscular damages, gastrointestinal distress, kidney damage. The list is pretty extensive. So, we also have to be aware that these contaminants, if they are being released onto environment, do have to be at a particular threshold for them to be harmful to humans. And in some cases, those thresholds are being exceeded, and that's something we want to prevent. So again, talking back about those PBDEs to give us a more specific example, PBDEs, they persist in the environment and they do something called bioaccumulate, which so they get up, they end up in our waters, they get uptaken by fish, and those continue to accumulate those in fish, and then those fish are ingested by humans, and the amount of accumulation can be to dangerous levels, and those PBDEs are shown to be bioaccumulative. And in the Great Lakes area, we found amounts already in fish and even in human beings.